Okay, and on my screen, you have a browser at a URL. The URL is pasted into the chat window. You can follow along. This is a webinar that is backed by 127,000 hours of tutorial. We will not be doing 127,000 hours today, but as Tricia mentioned, we're going to talk about React and TypeScript, but Tricia and I are going to talk about some ways to look at that through the lens of test-driven development, which is an interesting take on that combination. Along the way, we're going to talk a lot about getting into the flow and letting the tool help you stay in the flow by doing the janitorial work for you. Tricia, you and I have talked about this. You've done some quite a number of speeches and material on IntelliJ IDEA about the flow. What does that mean to you?
So one of the things I like about IntelliJ IDEA, and I hate to sound like a salesperson for the product, but this is what I liked about it as a developer before I started working for JetBrains, is it really does help you stay in the flow. And by in the flow, I mean that you're sort of typing the code that you kind of want to see. Obviously, IntelliJ IDEA is offering you things like code completion and suggestions. That helps you you don't have to know the answers to everything. It's kind of prompting you. But also, if you're doing something like TDD, you can kind of design how you want the code to look in advance and then use IntelliJ IDEA to create the code for you so that you can use Alt-Enter to kind of generate stuff as you go. So for me, that's what I mean by being in the flow. It kind of just, IntelliJ IDEA is a tool that enables you to sort of keep thinking and then kind of write what you want to see, and it kind of enables you as you go along.
Well said. This webinar is probably 50% about what Tricia just said and 50% about learning React and TypeScript. So let's jump into it. This is, as I mentioned, backed by a bunch of steps of a tutorial. For example, the first step of the tutorial has a video narrated by me that could easily replace your presence at this webinar, but we want you to engage and ask questions. Then an in-depth write-up of everything, including a link to the source code. So going into this so that you don't have to watch JavaScript tooling, spending a year downloading 100,000 packages, I've already run this command. In fact, I used it with Yarn. I'm going to wind up updating this tutorial to support the latest and greatest in React and its scaffolding tool, Create React App. So I've already run this, and we're going to be starting at this point on the tutorial. If you hear this in the background, that's me following along with handwritten notes about this tutorial. So I'm going to switch over to IntelliJ IDEA. I'm sitting in this project. I've got this set up a little bit the way I work, the Darkula theme. I've turned off the tool windows. I've turned off some of the toolbars. And as you will see in a moment, I've turned off tabs. And then we're going to turn off one more thing a little bit later on. I'm in this project. It doesn't have any Java, anything anywhere. It's just a front end project showing that we kind of kick ass. Why do we kick ass? Because we bundle WebStorm, and WebStorm kicks ass. So most of our IDEs can do high-end production level development of front ends through the inclusion of WebStorm. What I did to get here was run the Create React App scaffolding tool. The world of React is big, and you need tons of tooling written in JavaScript in order to have a sane development experience. That sanity gets insane quickly because everything changes every single day. Create React App keeps you sane by doing all of that configuration work and version pinning for you and giving you a great out-of-the-box experience. The command that I ran added the -- TypeScript flag to generate a TypeScript project, which is now a first-class citizen in Create React App. So I'm in here. The first thing I want to do is see a page. And how can I do that? Well, I could do it the normal way without the IDE helping me any. I could say npm run script start, and this starts up the Webpack development server where everything is running in memory. And once everything is transpiled, it gives me a running instance of the application in my browser served up on port 3000 localhost. And this is kind of the cool thing about the experience. I can come in, put in an exclamation point, save, it rebuilds, and before I can get back to the browser, it has reloaded itself. I put these side by side on my monitor, and I've got a great development experience. We're going to see a little bit later how to eliminate this terminal window with something a lot slicker than that. Now, before getting into that, we have the ability to run things in a tool window instead of a terminal window. So I'll close this. And the first way I could do it is I could go to package.json and say, show me the NPM scripts. And it's going to show me the scripts that are listed in my package.json. So let me talk about this for a moment. Modern web front-end development, if you're not familiar with it, uses Node.js, which is the JavaScript engine in a kind of desktop server-side environment instead of a browser. Node.js projects are signified by a package.json file, which specifies your dependencies, some other metadata, and a little bit of tooling, these script files. I could browse those with one of our tool windows and double-click on Start. But the way I prefer to do it is to come over to the package.json and click on Run Script with this icon here to run Start. And it does the same thing in a dedicated tool window and brings up the browser, which is a kind of a neater way to work, being able to walk up to these. You'll note this. We'll get back to that in a moment. The package.json does a number of things, but it's moved a lot of the work out of your configuration file into the Create React app project, which pre-wires a lot of the configuration for you. What else can we do out of the box thanks to Create React app and these NPM scripts? I could run some tests. For example, I'm going to run this, and it's going to run. We're going to see a much better way of doing this in a moment, in a more visual way, but it's running a test runner that as I type in my tests, and I'll say expect 1 to be 2, and I save, it reruns my tests and says that one of them failed. And if I change this back to 1 and save, then the tests work correctly. Then what else can we do with these NPM scripts in package.json? Well, I talked about Start being a kind of development server. Everything is in memory. Not only that, it's not building production quality output. It's not minifying all of your JavaScript. It's not tree shaking it to make it as small as possible for 2G phones in Africa. That's what this build script is for. When I run build, it's going to perform this action in the React scripts package, and it's going to make my CPU fan get all happy, and it's going to create an output directory with all the files needed for this React front-end project. I can copy the index.html and everything else up to my static hosting site, and I'm good. Now, one thing you're going to want to do in IntelliJ IDEA and all of our IDEs is you now have 2 copies of everything. You got all this JavaScript in here that is minified and stuff like that. And you don't want the IDE to look at it. So go right click on it, mark directory as excluded, and we will not index that. We will not try to autocomplete on it. And as that is being built constantly, you won't see the reindexing progress bar all the time. Okay, so that's it for production builds. What we did in this step was we kind of got oriented with the idea of Create React app, of a project with a package.json. And the package.json had some of this tooling that let us have a developer experience, a production experience, and a testing experience. I'll stop at this point. Tricia, got anything?
Yeah, so I found that super helpful because, as you know, this is not really my thing, but it is sort of fairly familiar to me. The scripts thing here looks quite a lot like the way Gradle scripts work for Java applications, and the way that the application has been created up front with the React app. Create React app reminds me a little bit of how the Spring Boot stuff works. So it's kind of nice to see, and it's consistently displayed inside the IDE. So the npm window looks a little bit like the Gradle window, and the way you run things looks a little bit like the way that you run things if you're running a Spring Boot application. So it's nice because it's sort of fairly familiar. But I did like the way that you explained what the different scripts are, because when I've been playing with these things before, I didn't really understand the difference between what was the script for running a development environment versus what I needed to run to actually generate the real application that was going to be deployed somewhere. So that was super helpful.
Yeah, that's a good point. And I need to emphasize that a little bit more, because this world of front-end development in JavaScript has gotten pretty industrial.
Yeah.
And if we were to take a peek inside node modules, we'd see a trillion dependencies that get pulled in order to do a teeny tiny hello world web page. It's kind of insane, isn't it?
Yeah, and we have the same thing. We joke about the same thing in the Java world. We talk about when you start Maven. So we have two build tools which also manage dependencies. We've got Maven and Gradle. They basically do the same thing. They're just configured in slightly different ways. But we always joked about Maven, like when you start Maven, you just download the world.
Yeah, right.
You download your dependencies and their dependencies and their dependencies. So, but it's the same sort of mental model.
And to connect back to what we discussed before, those tools help manage the insanity, right?
Yes, yeah, oh, totally. Because I remember back in the olden days when I was a bit younger, you would try and run a sample tutorial like this from the internet, and it would you'd be importing classes, and you'd be like, well, I don't know which libraries they come from. I don't know where to get that library from. I don't know which version that is. But when you've got build tools that manage those sorts of dependencies, it just makes life a lot easier.
Yep. And the further point to tie back to what you and I said previously, those tools help manage the insanity of all the dependencies and huge projects. The IDE helps manage the insanity of those tools by doing your janitorial work for you.
Yeah, and the ability to actually run each of those scripts from the script itself, the ability, things like code completion, and I don't know if you've got this for this tool, but in Gradle and Maven, for example, you can see a list of those dependencies, and you can drill down to see which packages are coming in and which classes are in those packages. So the IDE really helps sort of manage that complexity, as you said.
Right. And to answer a couple of questions that I see coming up, there's one about visual does not equal better with a smiley face. That is debatable. I see your point. But for people who do believe in IDEs and do believe in the I in IDE, this tutorial and this webinar is attempting to make the case that we can do a good job keeping you in the flow using these techniques of visual. Also, I will not be going into service workers in this one. So head on.
I have a point. I do have a point on the visual is not equal to better thing, which is that opinion is opinion. That's completely fine. For some people, visual is easier. And so we can't always be doing things from just one point of view. You know, you can't always teach things from the command line because some people just don't really get that. And that's fine. You have different ways. And if you don't get on with the visual stuff, then there's always terminal and other ways of doing stuff too. So it's nice to have both.
Yep. And to the questioner, instead of trying to convince you that it is better, I'll just convince you it sucks less. How about that? All right, so onward. We're going to go to the project cleanup step now. So that will be the next step. And we're going to get our code ready to start writing our application and showing some of the TDD features, and along the way, see some benefits that the IDE can give you. So for example, I've got code in here, and it's in the formatting that Create React App generated for me. But it's not in the formatting that I've got set up for my project. Well, I could go hit two spaces, or I could let the IDE do my janitorial work for me with the action that I do 100,000 times a day, reformat code. And you see that I've got the plugins to show the commands that I'm running and the keystrokes for it. Reformat code is something that you will do quite often. I'll do it again on the app.tsx. I should mention TSX files are the TypeScript flavor of JSX. What's JSX? It is HTML embedded in JavaScript. And then there's tooling along the way, which digests all of this into, called Babel, which digests all of this into executable code. It's quite slick when you have smart IDEs that can handle having the JSX in the middle of your code. I'm going to reformat the code here. You'll see that it makes some changes, and I'm good. Now, one of the things that it did, it added a semicolon because I went into my preferences and I said, I'll say semicolon, code style, TypeScript, and I've got it set up to always use semicolon to terminate statements. And then what that means is even though it came out of the box like that, nope, let me do this. And the IDE gives me a warning saying, hey, unterminated statement. I don't have to go clean all that up. I just reformat code and I'm in good shape. So onward, I'm going to change all of this. I don't need all this stuff. I'm going to write a very simple application. So I'm going to replace it with a div with an H1 in it. And I could write the opening tag, the div, and the closing tag and all that. Or I could use something called Emmet, which is a shorthand HTML system. And I do that and hit tab, and it generates my stuff for me. Yay. And so I can say, hello, React. Now I got my markup in the way that I want for getting started on testing. But I see that the IDE has now done some help for me. I've got an unused import. Happens a lot. But my cursor is here. My brain is here. I don't want to go there. And that might be 200 lines down the page. And I don't want to stop what I'm doing, context switch, and go fix my imports when all I have to do is let the IDE do it for me with optimized imports, which removes your unused imports. It sorts your imports. It consolidates things into one line, all based on preferences for how you want that done. So that's cool. But now that I just removed that CSS file, I want to delete it because I'm not using it anymore. And I also got rid of logo.svg. Actually, no, sorry. I'm going to delete this line. And so I'm going to delete the file that was pointed to by that and this file, which is no longer used. Watch when I hit delete, the IDE is going to say basically safe delete. Are you sure you want to do this? I'm going to check and see all across the project if you use those files. And that's because we're an IDE, we're not an editor. We don't look at files, we don't look at strings, we look at projects and symbols. And we know where everything is used. So I'll say, hey, yeah, sure, go ahead and check this for me. Turns out it wasn't used anywhere, so I'm safe. And now when I restart, it won't have the problem with that compile. Am I right about that? Or, oh yeah, good. All right, and I think I'll put that back in Chrome. Okay, good. Yeah, thanks, Safari. I didn't even upgrade to Catalina, it's still broken. What else can the IDE do for me? Well, imagine I'm like, oh yeah, see, I'm not using index.css either. I'll delete that file. What happens when I do safe delete? It says, whoa, dude, wait, slow down. You're using that. Are you sure you want to delete it? Well, where am I using it? I'm using it in here. What is it? Oh yeah, I am using it there. I'll just not delete it. It's still in use. So that's good. The IDE can also help me navigate around in my front-end projects, just like you would expect in your Java code. So for example, I'm sitting on app and I want to go find its declaration, and I do go to declaration. I want to find the usages. I can say find usages, and it tells me all the places it's used. Now imagine I like app, that's pretty boring. I want to change it to my app. No, I'll then have to go look and find all the 527 places it's used. I can't be bothered. Well, what if your tool could do it for you? It could not just do the rename, but go find all the usages and do those renamings. That's probably normal for you. You can do that in your front end as well. So I'm going to rename this to my app. Watch what happens when I hit enter. The WebStorm team for the win. We in the world of React, there's a convention that called single responsibility principle, that the name of your default export component should be the name of the file. It's like, okay, thanks for doing that. So I say yes, it renames the file, fixes my Git commit, and goes to the other end of that, which was in app or in index, and fixes the name of the import for me. And so we're all good. What if, and actually what I could do is I could do the refactor from the usage side as well. I don't have to go to the definition. But what if I decided, oh my God, that was a stupid idea. The boss really likes app. Now I have to go to all those places and clean it up and fix my get file and blah, blah, blah. Fortunately, all of that is in a single editor transaction that we can undo, and it fixes the name, it fixes the export, it fixes the name of the file, and it fixes all the usages of that file as well. Okay, on to another thing that the IDE does for us. This is a really good example because it kind of gets into the semantics of React JSX specifically. Let's say I write a component and I forget to import React. Well, that's a foul. Why is that a foul? Because if you don't import React, this whole JSX thingy is a no-op. So I go on here and it tells me what the problem is and allows me to do an import. And it will go and generate a TypeScript compatible import for that. Thank you very much, WebStorm team. That was awesome. Then let me mention that a little bit. I'm going to go back to not having it. And let's say I have a ton of code, and this is like off the screen from where my import is. What everybody does is they go and put their import, and then they come back to what they're doing. Don't do that. Let the tool just start typing, in fact. Just say React, and then do a completion, and hit enter, and it will do the autocomplete and generate the import for you. Let's see, you should have done that. All right, so we're back to being good on that. We talked about adding imports. The renaming of the usages really helps you move fast, stay focused, stay in the flow, let your tool do all the work for you. So I'm going to stop at that point. Trisha, got any questions?
Right, questions. There are a bunch of questions on here. A lot of them been handled on the back end, so that's been good. I mean, all of this stuff should be very familiar for anyone who's been doing Java development inside IntelliJ IDEA. I get the feeling, I might be wrong, I get the feeling that generally speaking, when people have been doing web development, they haven't been using tools like the ability to navigate through their code, doing things like refactoring, the save, delete, rename, all of those things. But I think from my experience in the Java world, this is something that we do quite a lot, especially because we have like this really strict type safe language with loads of boilerplate. We kind of we need the IDE to kind of generate a bunch of this stuff for us. But what I found is really helpful for me is that when I move to another language, like when I'm doing JavaScript, particularly TypeScript, having all the same functionality available in that language is super familiar to me. It means I don't have to learn everything all over again. I can just rely on the tool to do a lot of the stuff for me.
All right, I'm answering a couple of questions. All right. So there was a point about, hey, let's get to the React and TypeScript and TDD stuff. So guess what we have next? We have the testing step. All right, so we'll get into the TDD part now. Anything else you want to add before we get into that?
No, I want to get into the meat of the thing.
Yeah. And sorry, but with these webinars, we will get a survey saying you went too slow, and we'll get the next comment, you went too fast. So we just try to balance these things. Okay, onward into testing. In this step, we're going to move to doing TDD for our component development, for our React component development. And the first thing we're going to do is have a much better way of doing development by having a dedicated run configuration. Instead of this npm tool window, we're going to have a just run configuration. I'll leave it as all tests. Nothing I need to do here except say watch everything instead of just watch for changed files. Thank you, WebStorm, because this is a pain in the butt getting Jest set up correctly. All right, and I will say apply and OK. And now when I run my tests, I get a tool window down here, which has what everyone in IntelliJ IDEA would expect, a visual way of doing all of my testing. This should be familiar because we use a lot of the same test tool machinery. For now, I could even go turn off this start script so we're not doing 2 transpilings of everything. And we're good. I'll go back to my tests and show that if I change that and save, I get a much better formatted output. Not only, actually, I'll put it back in the fail. Not only do I get the better formatted output with all the things you expect, I get a gutter decoration telling me the exact test that's failing, and I could run it alone, and I get a little squiggly on the assertion that failed, which is a nice touch. Okay, we are going to get into the business of failing faster. So to fail faster, I'm going to, to speed up a little bit, we just showed that about the expected, and then get into a little bit of TDD basics. Here's the way I get into TDD mode to trick my brain into thinking, don't write code, write tests. I turn off the project tool window. I already have tabs turned off. So I want my code on the left, I want my test on the right, visual test runner output in the bottom, but I've got tabs turned off. So instead, I will do splitting. My test is over here. My code is over here. My test run, and as soon as I see that, my brain switches into the flow of TDD, where I'm working first here and then second over here and keeping an eye down here. So I'm in good mode on that. I'll just prove that it's still working. And next up, we want to do a real test. And I want to come back to my write-up and show a couple of steps I did just to speed things up. I'm installing an assertion library called Enzyme, and I didn't want to make you sit and wait for that download to happen. And Enzyme needs to be configured to work smoothly with React so that you don't have to type this adapter into all of your tests. So I made a file like this, and so I'm going to just speed up a little bit by copying this. We're going to make our first TDD kind of test. I'm going to paste this. And the IDE helps me by telling me, hey, you're missing an import. So I click on this and let it generate the import for me. We don't need to do any reformatting. And when I save, it runs. All right, great. So I'm in good shape with the test that I wrote for the feature that I added previously about that H1. For example, if I came over here and changed my code, then I would be out of date with my test and it would fail. What is this test doing from a web development perspective? I'm in a test runner called Jest. It's the most known test runner for the world of React. I plugged in this extra thing called Enzyme, which has kind of more convenience for mounting DOMs and getting shallow DOMs to speed up your testing and to have assertions and promise-based semantics and things like that. So I've added those things together. I wrote a test for rendering the heading. It grabbed my app component. You see it's imported from here. This is the app component. And it mounted it with the, loaded it with the shallow renderer, which doesn't go into subcomponents. And since the world of React wants to have lots of tiny single purpose components, that is a great way to do it. Gets the wrapper and then lets me look at the rendered output and make these assertions about the markup. So now that the markup is fixed and changed, I rerun and that assertion works okay. To see TDD really in action, I'm going to make another test. It should, I won't say should, it renders the paragraph. An arrow function. And I will copy these two for convenience purposes. And instead, I will get the paragraph tag. When I save, it will fail. And I want this to say nice TDD. And it still fails because I haven't implemented it. Alt tab to come over here, put in a paragraph that says hello TDD, save. Let's see, what am I missing on this? Oh, nice TD versus, yeah, good, see, TDD. I'll pretend that I meant to do that. And now I wrote a test, I wrote an implementation, and I had the visual test runner at the bottom keeping me sane the entire time. I never went to a browser. And that's the point of this whole tutorial, is to do your React development, your component development in the IDE and letting it keep you in the flow. I'll stop there for any questions, Tricia.
No, I think you must have answered everything because there's no questions at the moment.
All right,
I really like your way of doing TDD. I actually would love to do another webinar where like I do my Java TDD and you tell me like what I'm doing wrong. Because
oh gosh, no.
is it a slightly different way? I've never thought about having the two bits of code side by side. I actually quite like not looking at the production code. I kind of want to focus on just the test and think about my ideal of what it should look like without being colored by what it does look like. Do you know what I mean? So be more.
Yeah, but you're presuming that it looks like anything. If you're writing your test first, there is no code, and you're just failing constantly as you're thinking about it.
No, it's true. That's true. I mean, you still want to do it step by step like this, but I tend to flick between the two. So I'm in my test, I write my test, my one test, and I'll say something. I do this mostly for API design. So I say something like, this is the method I expect to be on this object, and it's not there because you haven't created it. You get IntelliJ IDEA to create that method. You return something empty, and and build it up iteratively that way. So, but doing it side by side, I think is a really nice idea. I never thought about doing that, particularly with something more visual like this.
Right, and the bigger point is stay away from Chrome. This whole mode of write and switch over to the browser and maybe switch over to a terminal window with your test runner and constant, like 5 times a minute context switching is for the birds. We had a question about would I actually write tests in such small increments? Yes, because the world of React has mega embraced small increments. The moment that this gets any state or any event handler, they want you to make a new component, to the point that the WebStorm team actually gives you an extract, convert to component, to extract things and make all those teeny tiny little pieces that would go with components. So yes, even though this looks silly because it's a paragraph of static text, it actually shows the way a lot of these tests actually work.
I really like the way it works really quickly, the fact that tests are automatically run. I think you can do that with the test that I write, but I must admit I haven't tried to set that up yet.
All right, onward. I'm going to talk now about debugging. And this was a real breakthrough for me to combine visual coding and visual testing with visual debugging and to change the way I write my code. Let's say that I'll do a little cleanup. I'll take this out. Take this line out. And let's say I want to add a parameter so that this is a little bit more dynamic. So I'm going to add an arrow function with some logic. If this was a TypeScript class, this would be a method on the class. So let's say I say label equals, I'll make it bracket, but it's really just one line. So for now, return, and I will say hello React. And I'm doing this as backwards. I'm not doing it as TDD, but we'll get back to that in just a moment. The IDE gives us a little warning that I haven't done some of the, I'm not using it. And so both the IDE is warning me and the linter is warning me. That's one thing I didn't mention is out of the box, it's set up a linter. The world of JavaScript might not be familiar with what that means, but these dynamic languages don't always have a compiler. And so all these linters like ESLint and Prettier for styling are a pretty common part of the tool chain. Okay, now in order to render this heading with the label, I'm going to want to change my H1 to say label and do the autocomplete. Warning goes away. When I save, my test still passed because I really didn't change kind of the outer external interface to it. But I don't really have a test for this label thing. What I really should do is move this out so that I can test it and export it. Come over here, and I can write a test, which I should have done from the beginning, generates a label. And what I want to do is I want to get the label. And look, it will automatically complete this for me. And, oh, no, that's not the one that I wanted. Alt import. Generate the import for me up at the top. It's getting it from app. And I'm going to get that, and I'm going to make an assertion saying expect L to be hello React. Reformat, save. And good, I now have it set up for TDD. That's working pretty well. But what's neat about this test is I didn't have to do the whole React DOM, fake DOM with JS DOM, component, anything. This is just code in a programming language. The programming language happens to be TypeScript in this case, but I can write a very fast test by extracting little pieces out of the big component into easily tested stuff. Let's say that, okay, we want to make it a little more dynamic, and we want the word, the person we're saying hello to, we want it to be European style and have it be all uppercase. I was about to make a joke about British style versus European style, but too soon? Probably
too soon.
Too soon. All right. So I'm going to change this to break my code to be all uppercase, to break my test, rather. When I save, my tests fail. Right? So good. My tests failed. That's what I wanted. I'm going to parameterize this by passing in the name. And when the IDE warns us, telling us, hey, you've sent an argument, we weren't expecting an argument. And so I'm going to put in the argument here. And now to use it, I want this, instead of returning a regular string, I want to use the ES6 string template thing. I could go change these ticks to backticks manually. Wouldn't it be nice if the IDE would just do that for us? Yay! All right. And this is what I want to change. I get autocomplete in here. I save. And look, my test pass. What? Nope, my test because, oh, I haven't done the logic to uppercase. This time my test pass. Yeah. No, because I'm passing a name. Oh, I need to destructure this. Is that right? Nope, that wasn't it. Because, let me look at this.
You need to give it a type?
No, I mean, I do need to give it a type, but that's, unless TypeScript was getting mad at me about that. No, that wasn't it. So undefined because label, oh, I'm sorry, duh, this is actually part of the flow of it. My test isn't passing it in. Over here, my implementation was passing it in. So here I need to say React. Gotta keep an eye on what the actual problem is. All right, so that works correctly. I'm uppercasing, and this was TypeScript adding type hinting to the equation for front-end development. So I put a type on the argument to this arrow function. Without it, I wouldn't have been able to do the autocomplete of the to uppercase. How can it help? This is, in addition to staying in the flow, this is another thing that I'm pretty interested in with this style of development called fail faster. And what I mean by this, the normal way of writing React applications is to write code and reload in Chrome, and then go figure out what went wrong. Or ship it to your customers and let them figure out what went wrong. So the first solution is TDD. Get in this TDD mode, write tests, etc. But then in order to fail, you have to run the test. You have to have a test to fail. I would like to stay in the flow by failing as fast as possible using TypeScript instead of JavaScript and typing my own code, even if I'm the only one that's going to use it, helps me fail faster because the IDE will give me a warning about this. And then when I fix this to put a string back, the warning goes away and my tests pass. All right, on to the part about debugging. Let's say that no
We've got a
matter
bunch of
what happened,
questions.
sure.
Do you mind taking some questions? Sorry
Yeah,
to
sure.
interrupt you. You must have done a really good job with the testing because we've sparked a bunch of creative questions.
Oh, good.
Um, I hope it's not going to sidetrack you too much.
Nope, nope, nope.
First question was, is it possible to do property-based testing?
Uh, property based. Yes. Let me switch to here. When we get into sharing prompts using type information, then it shows that completely.
Oh, cool. That's
We will
good.
not be getting there today.
But it's in the tutorial.
Yep.
There's an opinion-based question. When writing these tests, which pattern do you think flows more nicely with TDD? Given, when, and then, or the 3 A's, arrange, act, and assert?
I come from Python, and so we have something more like the latter. I believe this is the canonical style, at least in the world of React.
So that's the sort of follow on from that was, do you have any recommended tools that support either of these patterns? I guess it's kind of down to the testing tool.
Yes, that is the chicken answer. That is the coward answer. It happens to be true, but it is cowardly. It
So
brings up
I'm
kind of a meta question. I wrote this tutorial about 2 years ago, year and a half ago, because everything I found about React plus TypeScript was wrong and outdated. And I just needed to write down something for myself to remember what to do. And then I thought, oh, I'll share it with others. And so I turned it into a tutorial. One of my lessons learned bitterly is the moment you get teeny tiny outside of the mainstream in the world of React or Angular or Vue or whatever, you are toast. And TypeScript was not that popular 2 years ago with React, certainly. And I could never keep up with the breakage. So if you adopt a pattern which is lovely, that's kind of like a code smell. What else you got?
Yeah. Sorry, I was still stuck on thinking about TDD and BDD because my experience is with given, when, and then actually, and I hadn't really heard of the arrange, act, and assert, but to me they sound like the same sort of thing, surely. Anyway, yes. So another question: is it fine to export methods Is it fine to export methods just to test?
You bring up an interesting question because the single responsibility principle really is about there's one export and it's a default export. I see a lot of people writing up default exports are evil in this new world of ES6 modules, ESM, and things like that. I don't know if I yet buy that default exports are evil, but the idea that there's only one export would mean that that is not a thing. And for me, that is definitely a thing. For a minimum, later on when we do an interface, this will have an interface on the properties that are passed in. And over in my tests, I sure would like to grab that interface when I'm making some sample data and stuff like that. I'm in favor of having single responsibility principle include multiple tiny units that are each exported and testable. So that I can extract things that don't require a DOM. Does that answer the question, you think?
I think so. I mean, this is, again, wading deep into territory that I'm not familiar with from a technical point of view. But from a testing point of view, in the Java world, we often have what sounds like a similar question. Like, is it valid to make a private method public just so that you can test it? Because a private method is supposed to be private to a class, and that means a test can't get into it to test it. And so there's often people saying, well, that's kind of, you shouldn't really be making it public because it's like violating the encapsulation. But on the other hand, if it's complicated, then you want to be able to test it. So
yeah,
there's a balance to be struck there. Often the kind of one of the answers there is like, if it's complicated enough that you want to test it, then you will be making it public in some form anyway, because something's going to be using it somewhere.
It's interesting having this conversation in the context of a Java community. Because, I mean, I come from a Python community background, from a JavaScript background. In TypeScript, is a different fish built by someone who understands, strongly typed, compiled universe completely. Anders is, probably one of the 3 most influential people of the past 20 years. And so hearing you talk about discrete units and standalone functions actually gets into a little bit of Kotlin too, right?
Right, exactly.
So I don't think that all of these things that were just asked by our loyal listeners and discussed by you and me are way ahead and more sophisticated and professional than the state of the art in the React community. No matter what you do, you're ahead of everyone else. Did I say
Fair
that out
enough.
loud?
You just complimented all of our listeners.
Oh, yes. Okay, good.
Let's move on before we start patting everyone on the back.
Now let's say that I had this 42 here and I'm like, what the hell? This has to work. I'm tired, been working all day. I can't see straight. And I want to go step into this and figure out what's wrong with my test, what's wrong with my code. I could do console log, but the test runner is going to capture it. What can I do? I can set a breakpoint and I can run this test under the debugger. What does that even mean? We are not in a browser. We are in Node.js. These tests are executing in a fake browser called JSDOM that is implemented purely in JavaScript and running inside Node.js. So I can use the Node.js debugger, which is beautifully integrated into IntelliJ IDEA thanks to the WebStorm team. This test runs, it stops on this line. I can step into my code and I can be like, I still don't get it. I see names 42, uppercase it for me. Well, I can take this line, highlight it, go to evaluate expression, evaluate it, see the output, and say, oh, what? I still don't get it. What is the type of name? Oh, it's a number. Oh, Paul, you're stupid. It's not a string. And that's how I get through my problems when doing React development. I sit in tests rather than the browser so that when I need a debugger, it's right there. I don't have to do anything special, and I'm super, 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 super productive. I will stop on this step at that point and see if you've got any points to add about debugging and testing.
Sorry, I forgot to unmute my microphone.
No problem.
Not really at this point. I mean, I just love evaluate expression. It's the most useful thing. It's just like poke at things and see what it is, see how it works.
Yep. But the idea of combining visual debugging with visual testing was kind of a breakthrough for me. It just really made me productive. Okay.
Again, I think the debugging side of stuff, especially for back-end Java developers, that's just something we've had to do because we don't often have a visual, we don't have a UI for us to look at. So from my world point of view, like without a debugger, it would, well, actually, having said that, we also use logging an awful lot to debug applications, which is why I quite like evaluate expression, because instead of putting loads of system out printlns everywhere, you can actually just like set a breakpoint, say evaluate expression, and poke it and see what is this thing, what does it look like.
So I'll take 4 more minutes. Instead of sitting in the IDE, I will go through the tutorial if that's okay and point out some other things. Is that all right?
Yes, sorry, I was muted again. Yes, it sounds like a good idea.
Okay, so needless to say, this could be a 4-part webinar, and but the good news is all of this material is available online, and you can continue along with it. If you did need to execute your tests in Chrome and debug in Chrome, then you can. This talks about setting up a JavaScript debug configuration pointed at the URL of the Webpack dev server. And then when you set breakpoints and tell it to execute, it's going to pop up a browser in a temporary profile. And then it's going to stop. It's going to return control back to the IDE and let you step in your IDE through code that's being inspected, evaluated in a browser, which is pretty cool. All right, then we get into some of the meat of the React and TypeScript development. We talk about this language called TSX and this modern stuff called ESX, the modern JavaScript, and how we can write components and write tests that have classes and fields that get into these standalone arrow functions that can actually handle events. Then we get back to pure functions, the way all modern front ends are moving towards standalone functions instead of classes, how to share state up and down your tree of components, your parent components, your child presentation components, how to do the same thing, not with functions, but with classes. These are all pretty interesting because they have interfaces which describe your props. And when that happens, your IDE can autocomplete for you for prompts and give you red squigglies telling you that you've made mistakes. For you Java developers, it becomes a really productive, familiar way of doing professional front ends instead of the script kiddie approach that JavaScript is most common with. Talk a little bit about state inside of components and then moving them up in this one, presentation container components, moving the state and the logic up to the parent and the parent component, and then ending with, or next to the end, but adding logic for event handlers. TDD can extend to capturing events as well as poking state and looking at the DOM and things like that. So I might have a click handler, move it out to a function, and then I can write a test which simulates the click. And then this is just an enzyme and JS DOM behind the scenes putting in little mocks for everything. And then after I've pretended to click, I can then look at my components rendered output and see if that click actually did what the implementation was supposed to do. So with that in mind, we have this 12-step tutorial about React, TypeScript, and TDD with working code videos, narrated videos, and lots of tips in there about getting into the flow, fail faster, and putting the IDE to work to be your janitor for a cleanup on aisle 5. Over to you.
Oh, this is great. I have one more question I didn't get a chance to ask you before, and then I'm hoping that if people who are listening have more questions, please, you've got 5 more minutes to submit your questions. Great. And then I can ask them to Paul. So this question was, can the new hooks approach also be tested like this? I'm not sure what that means.
Yeah, I will confess, I know hooks will solve my problems. But from a moral perspective, I'm kind of pissed off that this is like the third swing at sharing state in the component tree in the world of React. And I'm kind of just bailed out on that. And when I do my next change, I'm going to move to something like Emmer. But it's the question is, how would hooks, which is a React technology for instead of having to pass a piece of state down 20 components from parent to child to grandchild blah, 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 to get it kind of from the environment, it should make test writing a lot easier because your component is, the hook provides the component what it needs.
Okay.
Now, I will say if you want to test kind of an integration test of the combination of the hook and the component, you can also do that. It's just a little bit more setup.
Yeah, that sounds fair enough. It's always the case with sort of more joined up tests. There's always going to be more setup there. You have another question, which is, will you be doing a similar webinar for Vue?
No.
That's a quick answer.
No, simply because I'm not willing to. What I'm trying to do is show how I work. And that's opinionated. And I don't work with you and I don't have opinions. So I would be a fraud wasting your time. I would just be a shill showing things that I don't really understand. If I do pick up Vue, then I will certainly do something like that. But the next thing I'm going to pick up when I leave React won't be Vue. It will probably be HyperApp. I'm going to scale down rather than sideways.
Maybe we could find someone who could do a Vue webinar.
Yeah, definitely.
Because I know a bunch of people here in Seville where I am, a lot of them are kind of interested in the Vue side of stuff. I keep saying use Angular because I know about Angular, and they're like, no, but I'm using Vue. So yeah, maybe we'll make a note of that as a prospective future webinar for someone else.
Interesting how many questions we got asking for Angular, right?
Right. Okay. So there's a related question. Why do you use React and not Angular?
I started with Angular JS. I switched to Angular 2, and then I switched to React. Somewhat bitterly, because I made a promise to myself, wherever I take my hat, TypeScript will go with me, and React plus TypeScript was not a fun thing 2 years ago. But Angular became so industrial, and they were jumping through their butts to get bundle sizes small, to have execution time for TDD to be under 10 seconds. It just was so huge. I haven't revisited it in about a year and a half. It might be better, but it's huge.
Yeah. I've been using Angular a little bit when I've been playing with web front ends. I had to upgrade an app from Angular 2 to Angular 6. It took me it's a tiny demo app, and it took me like 2 weeks just to do that thing. I'm promising to come back to Angular. I'm thinking about, so I'm in the middle of doing a tutorial kind of similar to this, but not on the same technologies. A tutorial with with Kotlin on the back end, Spring Boot, JavaFX as the UI. We generally don't write Java user interfaces as a community, so I'm thinking of actually using that tutorial and then putting an Angular front end onto it and see how that works. So
I saw you got a tweet response of someone saying, great tutorial for the Spring Boot thing. Why'd you use JavaFX?
Yeah, well, the reason was because it was this is beyond the scope of this, because I needed to demo some stuff in Java, and JavaFX was the only user interface technology that I could have done that with. But yeah, I wouldn't choose to do that if I was implementing something now.
So just to wrap up on the Angular thing, I'm like the sweet spot for Angular. I want something coherent. I want something written under one roof. But they just so botched the move to Angular 2, and it took a year of cleanup, and I got off the ship. There's a question about Svelte. If you don't mind, I'll talk 30 seconds because I think from the Java community, it's an interesting thing to discuss. I find Svelte very, very interesting. It's probably the right way that everything will be doing things 2 years from now. Its approach is it doesn't ship a runtime. It is a compiler that happens to use JavaScript as kind of a DSL. And then it spews output, which is standalone. You don't have to include React, for example. You have to include some library. And because it's a compiler, it will tell you ahead of time all kinds of things that you did right or did wrong. It is just fascinating, written by the guy who does rollup. So he really, really knows what he's doing.
I must admit, I hadn't even heard of it, so I'm going to have to. That's on my list of things to Google.
Even if you aren't in the market for a new JavaScript technology, it is a set of ideas which is pretty compelling. It's kind of a little bit like Kotlin JS.
Right.
Where instead of Kotlin, it's JavaScript, but the fact that it's JavaScript is immaterial.
That's a good point. Actually, we didn't mention Kotlin JS, so we probably should have done. Kotlin can be used in more than one with more than one what's it called, compiler. So yeah, Kotlin is not
create React app Kotlin.
Right? Is there?
Yeah.
That's interesting.
Yep.
Very interesting. There's one more question here. Well, we are really running out of time. I just want to take this one last question. Open API. All right, that's a point for me. All right, I will look into that Open API thing for my demo. Great. Thank you so much, Paul. Do you have any other points to wrap up before we finish everything?
Give a try, if you're doing front ends, give a try to this TDD first approach. Give a try at staying in the flow. Give a try at fail faster. And thank you, Tricia, for having me. And thank you, IntelliJ IDEA Java World, for letting a Python refugee come over.
Thank you so much, Paul. This was really helpful. Well, I don't know about our viewers and our listeners, but I found this extremely helpful. There's a whole set of technologies I'm aware of, but not super familiar with. And it's really nice to see someone who knows how to work with them, working with them inside the IDE. So we can kind of see not just syntax, which you can see like in a browser anytime when you're Googling these things, but seeing how to work with the code, how to build the code, and how obviously IntelliJ IDEA kind of helps us to work in a way which is really familiar to us. So thank you so much.
My pleasure.